Solve for all the key features of the following function. Referring to the generic formula, the concavity is determined by the a value. If it's positive, it's going to be concave up. If it's negative, it's going to be concave down. In this case, we have a positive 3, so we're going to record concave up. Moving on to the vertex is determined by the h and k variables. Reminder that the h value is going to be the opposite of what we see. Since we have a positive 1, we're going to begin by recording negative 1. And the k value in this case is going to be negative 12. The axis of symmetry, that's just your h value, and we already recorded that, that's negative 1. We're going to write it as the line x equal to negative 1. For the x-intercept, we're going to have to solve for the equation. We're going to let f of x equal to 0, and then we're going to solve for x. Doing so, we're going to get 0 equal to 3 quantity x plus 1 squared minus 12. And now we got to isolate x. We got to solve for x. I'm going to first get rid of this constant here. Since we have a negative 12, to move it to the other side, I'm going to have to add 12. On the right hand side, negative 12, positive 12 cancel out. And on the left hand side, 0 plus 12 gives me 12. And we still have that 3 x plus 1 quantity squared. The second step is going to involve getting rid of this factor here. So we're going to divide both sides by 3 since we have to undo the multiplication. So here, divide the right hand side by 3, divide the left hand side by 3. 3 divides 12 4 times. And on the right hand side, the 3's are going to cancel out, leaving us with x plus 1 quantity squared. Now to get rid of the exponent, we got to undo the square. And to do that, we got to take the square root of both sides. On the left hand side, the square root of 4, we're going to get plus or minus 2. And on the right hand side, the square and the square root cancel out, leaving us with x plus 1. Now to isolate x, we gotta get rid of this plus 1, so we're gonna subtract 1 on both sides. And we get, on the right hand side, x is isolated. On the left hand side, we have negative 1, plus or minus 2. And we have two problems to solve. We have to solve negative 1 plus 2 and negative 1 minus 2. So beginning with negative 1 plus 2, that's going to give us 1. And then negative 1 minus 2, that's negative 3. So our x-intercepts are going to be 1, 0, and negative 3, 0. Now let's go ahead and solve for the y-intercept. And to solve for the y-intercept, we have to evaluate f of 0. So f of 0 is going to equal to 3, and we're just going to replace x for 0. Parentheses 0 plus 1 squared minus 12. To evaluate this expression here, we got to follow the order of operations. So beginning with parentheses, 0 plus 1 gives us 0. So we're left with 3 parentheses 1 squared minus 12. Next, we're going to evaluate the exponent. 1 raised to the second power, that's just 1 times 1. So we get 3 times 1 minus 12. And now we're going to go ahead and do the multiplication. 3 times 1 is 3. And then we subtract 12. 3 minus 12, that's going to be negative 9. So f of 0 is equal to negative 9. And if we write this in coordinate form, the y-intercept is going to be 0, negative 9. Finally, we're going to solve for y if x is equal to negative 2, or basically it's solving for f of x using our notation. So let's look at the equation one more time, and this time we're going to replace x for this negative 2. So we're going to evaluate f of negative 2. That's going to equal 3 parentheses, and again we're exchanging x for negative 2. So we get negative 2 plus 1 quantity squared minus 12. And we're going to follow the same process that we followed for the y-intercept. We're first going to evaluate what's inside of the parentheses. So negative 2 plus 1, That's going to give me a negative 1. And we have quantity squared minus 12. Now, negative 1 raised to the second power, that's negative 1 times negative 1, so we get positive 1. And here I have 3 times 1 minus 12. And now we gotta do the multiplication. 3 times 1 is 3. And if we subtract 12, we're also gonna get positive 9. So f of negative 2 is gonna equal 9. And if we write that in as a coordinate, we have the coordinate negative 2, positive 9.